Hello, welcome back. Today we are going to see the practical approach for arguments in Python. Then we have Lambda function. Then we have recursion in Python. We'll see one by one. Okay. So starting with the positional arguments. What is positional arguments? Value are passed in same order as parameters defined in the function. Okay. For example, you can see here. I will just comment this out. Okay. Def is your keyword, student is your function name, and two parameters we are passing, name and age. Okay, then here we have to make the indentation correct. Okay, so we are printing name and age. Whatever the name we are passing in the function call, this one is your function call. Okay, so whatever we are passing in the function call, it should match the order of function definition. This one is your function definition. Function definition. So it should match with the function call. Function call should match with the function definition, talking in terms of positional arguments. Okay, so when I run this, you can see version 25. Okay, now let's see the other example, that is keyword arguments. Okay, I will comment this out for now. What does the keyword arguments says? Keyword arguments parameter name while use passing the values. Order does not matter. Okay, for example, you can see def student name age, print name age. Okay, I will just comment this out. Okay, so in keyword you can see here we are using the parameter name, parameter and value are passing side by side in the function call. Okay, whereas in positional we are not passing the parameter and name side by side. Clear? So as the name suggests, keyword, we are using this as a keyword and passing the values, keyword and passing the values. Okay, so when I run, you can see it will show the value as it is, version 25. Clear? So this is the second case. The third case is default arguments. Okay, so when I comment this out, when I comment this out, you can see when I run this one. Okay, hello student, hello Oshim. Okay, you can, I'm passing here greet without any arguments. Here I'm passing greet with arguments. Okay, so if I would haven't give this one as, okay, greet name only, then I run this program, you can see type error. What is error? Greet missing one required positional, okay, name. So in order to get out of this error, we have to pass as the default argument. That is your default argument is your student. Okay, clear? Now if I run again, it will work fine. Fine, clear? Then if I again run, get again. Okay, now you can see it is taking the same default parameter. Okay, so this is how it works. Just comment this out. We'll see the next one. That is variable length arguments. What does the variable length argument means? That means the length of the parameters is not fixed. Okay, you can see this example. Def total, we are finding the total number. Okay, total equal to 10, 20. Either you can pass 10, 20, 30, 40, 50, 60, 70 and so on. Why? Because we are using this asterisk numbers. Asterisk means any numbers we can include while passing in the function call. Clear? You can see run 30, 100. Okay, so it is actually printing the sum. This is sum function, we are calling it sum of numbers. Okay, so this is how it works. So now let's jump into the lambda function. What is a lambda function? A function that is a small anonymous function written in a single line. Okay, so what this you can see here, this is your normal function. Okay, normal function means we are writing here. You can see how we know that it's normal function, because it starts with def and it contains return keyword. Okay, and the calculation is not inline. Okay, this is your normal function. Talking about the lambda function, we'll jump into a lambda function. This one is a lambda function. Okay, so when I run this one, you can see. So what is n square n? If I pass here 5, 5 5 is 25, you can see here the answer is 25. Okay, so in lambda function, just remember, whenever you create this one is your function name square, and lambda will be your keyword. Since we are dealing with lambda function, so you have to include lambda, and n is your parameter. Yeah, so after the parameter, we directly calculate our result. Okay, in one line. That's why it's known as inline function. Inline function, also known as lambda function. Then at last we are printing 5. Okay, so this is your lambda function. What does the recursion says? The function that call itself is called a recursion. Okay, that means the function will keep on calling itself. Okay, for example, this one, I will just comment this out. So first of all, I need to maintain the indentation. Okay, in factorial, just remember that the rules. Okay, the base condition must be present to stop recursion. So what is our base condition? This one, return 1. Okay, it will stop the recursion the moment it encounter 1. That is the base condition. The function must call itself. This one is calling. Okay, first it says what is the value of n. For example, we are dealing with 5. Okay, we are dealing with 5, finding the factorial of 5. Okay, 5 into fact is our this one. That is our function call. N minus 1, 5 into 5 minus 1, that is 4. 5 into 4, 20. Okay, so what is the factorial of 5? Let me type here. Factorial of 5 is 5 into 4 into 3 into 2 into 1. Okay, this is your factorial, 5 factorial. Okay, so you can see we have 5 plus n as 5. Okay, so n will be your 5 into fact of n minus fact is your function call. N will be your 5 minus 1, 4. That is 5 into 4. You got this one? Then again it will come here. It will become 4. Okay, 5 into 4, then 4 into 3, then 2 into 1. Okay, and so on. That means it keeps on calling itself. Okay, recursion means it will keep on calling the function itself to run and complete the program. Okay, so this is how it works. Fine, so I will just comment this out for now and run the program. So you will get the answer as 120. Why? Because 5 into 4 into 3 into 2 into 1 will be your 120. Clear? So this is the practical approach for lambda, types of arguments in Python, and recursion in Python. I hope it helps. So we'll see next topic in the next class. Till then, thank you.